All right, I'm gonna go ahead and get started. I'm Adam Keys. I work here in Austin at Gowalla, and we've been doing a good bit of stuff with Cassandra lately, and I've been building an activity feed database called Chronologic, and I'm gonna introduce that to you today, and then I'm going to give it to you. So just a show of hands, has anyone here working with Cassandra, just tinkering? Played with it, installed it, one person. Anyone have it in production? Just me. Okay, great. So we get to learn Cassandra together. So what is Cassandra? You've maybe heard of this thing that Twitter and Facebook started and other people are using. Is it a distributed hash table that's persistent and durable? Is it a column-oriented masterless database? Or maybe it's a Dynamo big table hybrid thingy that was based off these papers that Google and Facebook, or that Amazon and Google published. And the answer is yes, it is these things. It's Cassandra. It's whatever it wants to be, just like Zool. So a lot of talks on Cassandra will throw you knee-deep into the data model or be like, hey, it's this academic-y thing that makes sense if you know what Cassandra is already. But I don't want to tell you that. So it's like these other things that you already know. It stores keys and value and then opaque values, just like Memcache or Reoc do. It stores hashes like Redis does when you do hset or hget. It does sorted sets like Redis does, so you can throw a bunch of things into a row in Cassandra and you can test for membership, you can pull things out in order, you can page through it, etc. It's like that other thing. It also does keys and counters like Redis does. Cassandra has excellent support for atomic distributed counters, which is kind of jargony, but extremely useful. It does keys with keys and values within them, just like MongoDB does. So you can store nested document-like things inside of it. And it does rows and columns, just like MySQL or Postgres do, that we've all come to know and love. But the great thing about Cassandra is it's distributed. None of the nodes are special. Any one node can go down, and no one has to wake up in the middle of the night. Each server in your cluster is arranged conceptually on a ring, and every server knows about who the next servers are on that ring, and that ring is used to locate data on the cluster. So you have some key that you access data by, and you connect to a node, and you say, "Hey, give me this, give me the data at this key," and then that node knows how to find the data on the ring and bring it back to you, or it knows how to write the data on that ring and where to replicate the data to. Data is stored along this ring, and it's also replicated along this ring. So like I said, you can lose a node in the middle of the night, and your ops guy doesn't have to wake up, which they like a lot. Data, you specify how many copies of every row to keep in the cluster, and Cassandra will make sure that many copies are written somewhere in that ring. And you can specify whether the replication happens synchronously or asynchronously, and that's a nice tunable parameter on a per request basis. It's not like server global config. Each server in the ring knows about every other server, and they all gossip to each other. They talk to each other. They say, hey, I think this guy is down, or I think this guy is back up. We should send him the data that he was missing from beforehand, etc. And you can connect to any server. None of them are special. So like in Gowalla, we have our Cassandra Ruby driver, and we tell it about, when we instantiate that object, we tell it about all the nodes in the cluster, and then they can choose, they basically just choose randomly whichever one to connect to. Or you can just tell your driver about one node, and it can auto-discover the rest of the nodes by asking the server, which nodes do you know about? So Cassandra is also like all these other databases that you might know in terms of consistency, in terms of like the classic ACID profile. So in terms of durability, You can operate Cassandra with no guaranteed durability. You write something to it and it says, yeah, chief, I totally wrote that, even though it might not have, just like Mongo does and just like Memcache do. You can operate with full durability. So you say, write this piece of data, and it does not return to your client until it has actually written all of that data, has written every copy of that data to disk across the cluster, and maybe even to a data center somewhere way far away. You can operate with no consistency. So you can say, hey, just write this thing as fast as you can, and then if I try to read that back, it's okay if you don't show that to me. Or it can operate with quorum consistency. So you say, write this thing, and as long as you can get a majority of the nodes that are supposed to store it to agree on the value, then we're good. And you can operate with full consistency, where you say, don't tell me you've written this, or don't give me back values that aren't an absolute agreement across the cluster. And you can do any of this across racks or across data centers. So Cassandra is designed so that you can tell it about your network topology. You can say this group of machines is very close to each other. They're connected via 10 gig Ethernet. And these other machines over here are very far away, and they're connected via a T1 line. So don't go talking to it when you need to do something quickly. But do keep replicating data to those machines that are across a T1 from us. And so this comes in really handy if, for instance, a plane taking off from Dulles lands in one of Amazon's data centers, or if the data center just goes blank like it did a few weeks ago. So all these things, these are all all the NoSQL databases love to hate. So there's plenty to, it does everything that everyone hates about NoSQL databases, and it does everything that everyone loves. It's all things to all people. So why are we using Cassandra at Gowalla? We're using it for fast-growing data. We got a lot of check-ins. We have a fairly big social graph, photos and comments. People are creating stuff all the time. This data grows quickly. We use Postgres. It has okay replication support, but it's definitely not something where we want to put fast-growing data sets into that we need really quick access to after we've created that data. We have data that benefits from pre-materialized views. When you pull, if you pull your friend's activity in Gowalla, it's nice to be able to make one request and get all of the check-ins, all the user spot data, the photos, the comments, the highlights, the metadata, everything in one request, instead of having to talk a little to Postgres, a little to Memcache, grab a couple things out of Redis, maybe fetch something from Solar. It's nice to just say, hey, you database, give me this one thing. And we also, our ops guy really loves the master list design that accounts for redundancy and availability. And like I said, if we lose one node overnight, the system continues to operate. There's no elevated error rate. If we lose another node, then there's an elevated error rate for some pieces of data, but the site is still up for most users. So he likes that a lot. And I like that a lot. I like that he doesn't have to wake up in the middle of the night. So what specifically are we using Cassandra for? Last year at this conference, I started tinkering around with a way to store audit data when users change spots or various data changes in our system. We were writing an audit log to Postgres, and that table was growing very quickly. So I wrote just a little rinky-dinky little thing that stores that into Cassandra instead of Postgres. And that was a very easy project. It was low risk because we could have just keep using the other thing, but it was something that was going to give us a benefit. But it was by no means critical to the operation of our website, and so it was a very good training wheels project. So there's a gem in my GitHub called Audit, and that's how we store change logs. And the past several months, I've been working on this Chronologic activity stream database where you store activity feeds, check-in feeds, etc. And I'll go deep into this in a minute. What would we use Cassandra for? Caching social graphs from other networks. We do a lot of social friend matching against your Facebook and your Twitter friends, and it's expensive to make those calls, so we need to store it locally for a short period of time. This would fit really well in Cassandra. Like annotations, if you go someplace and say this is a great thing, that would be a good, if we end up implementing that, this would store really well into Cassandra, where it's like sort of a multi-level relationship, but generic. Out-of-band notifications. So right now we say, hey, your friend checked in here, and that is a push system, but it would be nice to separate that data out into something else. What do I want to use Cassandra for in the future? Redis is a really fun little database, and it is great. It's good software. You can store a lot of stuff in it. It's fast. It has a really interesting data model that people seem to come to understand and figure out how to use really quickly. But it's pretty much stuck at being a master-slave sort of replicated setup. Whereas Cassandra can do many of the same things, not all of the same things, but many of them, and you don't have to worry about pre-sharding or handling slave reads or whatever. You can just put Cassandra in place. If you know the Cassandra data model well enough, you can just put Cassandra in place, and it handles all of the tricky bits for you. Even longer term, I don't know a thing about. I know enough about Solr to know that I don't want to know how it works. There's a gizmo called where a guy here in, I don't know if he's in Austin, but one of the guys who works on Cassandra took Solr and replaced its storage with Cassandra, and that allows real-time index updates, and you don't have to think about all these index readers and writers so much. So that sounds like a nice thing. And there's if you're doing big data, Hadoop, there's a way to replace HDFS and its myriad of oddnesses and shortcomings with Cassandra. So you run a hybrid cluster that's running Cassandra and Hadoop on each node. You replicate your data into that cluster from your normal Cassandra cluster, and then you can run Hadoop jobs on that cluster, and you don't have to worry about your name node going down or anything like that. So that would be a real nice thing as well. So what would I not use Cassandra for? Some things it's just not great for. Geo searches, location searches. I am completely fine with continuing to do that in something like Solr. There is a way to do the data structures you need for geo searches in Cassandra. That's what Simple Geo is doing, but I don't want to go understand those algorithms. Heap-based caches. Memcache is great. Twitter, in fact, runs Memcache on their Cassandra servers. No need to replace that. Highly normalized relational data. You can't do joins in Cassandra, at least at the database level. And so if you want to do ad hoc queries, you're kind of SOL with Cassandra. You can use Hadoop, but that's a whole other thing. Small data sets. If something's going to be, 1 million rows or less and never get any bigger than that, then, MySQL, Redis, whatever, that works great. And for prototypes, for things where I don't know what the queries are going to be, what data is going to be important and what data is going to be irrelevant, what I'm going to need fast access to, and what I can take my time fetching, I wouldn't use Cassandra until I really know the application really well. When I'm still figuring it out, I would use something that has ad hoc queries. So, 6 easy pieces on Cassandra. I'm just going to try and fly through this just to explain what Cassandra's data model looks like, and then this is actually the way that Chronologic stores some data. So our pieces are going to be showing that Cassandra is like SQL with beer goggles, how to store keys in blobs like Memcache. We do this for events. How to store keys in columns like hashes in Redis. This is how we store objects that events reference. Simple social graphs. This is how I store how people subscribe to events. And then timelines. When you actually fetch an activity feed, this is how you would do an index, like a hand-built index in Cassandra. And then Cassandra also implements secondary indexes, which are very comforting if you're used to a relational database where you have a primary key and then you index the columns that you query on frequently. So, beer goggles. This is how you create a key space in Cassandra. A key space is roughly analogous to a database in Postgres or MySQL. This is how you create a column family, which is roughly analogous to a table in relational databases. The first version is the simple, easy version, and the second version is more specifying things with more detail. You're telling Cassandra how to sort the rows. You can do range queries in Cassandra, and how to sort columns, and how to validate what is going into them. And it's actually specifying a column name and saying this specific column name is sorted as UTF-8 characters. This is how you delete tables or column families, and this is how you drop the entire database or key space. So that all looks just like, looks very similar to SQL. There's a Cassandra CLI program that you use just like the MySQL or PSQL REPL. So it's pretty easy to get used to. So that was, a little boring. Pardon me. Keys and blobs like memcache. So now I'm going to switch over to using the Ruby Cassandra driver. I'm going to create a new connection, and I'm going to use an LSRC key space. I've got this hash of data that I want to store into a column in Cassandra, so I'm going to insert it into the example column family. The name of the key is AKK, and then the column name is data, and then the value is a JSON encoded string that I converted that hash to. So then I'm going to read it back out. To do that, I just do a get. And again, I specify the example column family and the AKK row key, and then I'm going to get back an ordered hash, which is basically a hash in Ruby 1.9, but it's been backported to 1.8. And there's a data column, and then you can see the very beginning of a JSON encoded string there. And then there's also, it returns data and then a timestamp. This is for if you need to do concurrent writes. You can submit a timestamp, and that way nothing gets overwritten because an old read overwrote a newer read. And then I can delete the row with remove AKK. Keys and columns. So this is like a hash. Again, I have the same structured data, but I'm submitting the entire hash this time. So I'm going to have two columns this time, username and age, and their values will be AKK and 31. And you can see that roughly reflected here. And you see that this time I get two timestamps, and then I remove the data again. So that wasn't too perplexing. Social graphs. So this is like a subgraph of my followers on Gowalla. We're saying that this thing on the left, user RS feed, is connected to user RS, or I'm sorry. This is the people who follow me. So on the left side is the feed that follows me, and on the right side is the user that follows me. So when I insert this, I'm inserting 4 columns into the one row AKK/graph, and then I can get that hash back, and then I can get my followers by looking at keys on that hash. So my followers would be RS feed, BF feed, AM feed, MT feed, and the people that I actually follow back are the guys on the right. And you eject for empty strings. So that's a really simple way to sew a social graph. I'm trying to hurry through this so I can get to the actual things I'm going to release to you at the end of this talk. Timeline indexes, we store events as columns. I'm just going to speed through this and we can come back to it. I want to show that, so here's how you create a column family, and this column family has indexes on the age and username columns. So I insert some data in with the Cassandra CLI. So I'm inserting 4 columns, username, age, bio, and admin. I do that a few times. And then I can say get users where admin is true and age is greater than 18. So this is something that you can't typically do. You can't do this with React. You can't do this with Memcache. This comes in very handy. And there's actually, I say it's like SQL with beer goggles. Cassandra 08, the latest version, ships with something called CQL, which is basically a subset of SQL with no joins and limited subset of SQL that lets you query Cassandra without using the API. So these are all things that Ron Swanson would love. Okay, so the meat, Chronologic. It's a service for storing event data, their related objects, mapping that to a social graph, and then assembling feeds of these events and objects and sub-events. So I work with artists, very awesome artists who draw icons all day, and so I got a cool logo for my project. So events and object references. People generate events. It might be like a status like in Twitter, a check-in like on Gowalla, a photo like on Instagram, or TPS reports in some boring IT application. And those events refer to other objects like users, locations, photos, stored somewhere else, documents, etc. But they're not really the activity. They're just ancillary data that you need to display a pretty looking timeline. And those events are related to users via social graph. So people connect with each other, so they follow each other, they friend each other. I might manage someone or report to someone, and that's a connection that is meaningful to Chronologic because it indicates where events need to be written to once they're submitted. So people want to know what other people are up to, so they want a status feed, a check-in feed, a photo feed, or whatever. And the social graph specifies that when I post something, all of my followers should see it in their feed. Or when I push something to GitHub, everyone who follows me as a user and the repository that I just posted to should see that in their activity feed when they log into GitHub. So applications replicate their objects and social graph into Chronologic. Our primary store of, say, users and spots in Gowalla is in Postgres, but we mirror that data into Chronologic so that it can pull a complete activity feed without having to touch outside systems. So the record is the verb that's used in the Chronologic API, and then application subscribe is the verb to other timelines. So you say when an event gets written to Adam's check-in timeline, it should also appear in Bob's timeline. And so you can also say that if there's a check-in to Torchy's, then it should appear in the global taco truck feed on Gowalla. You could do that as well. So applications publish events. So you've got some application that's using Chronologic. Whenever someone checks in or creates a new document or pushes something, then an event is created in Chronologic. And that's called publishing. In Gowalla, we publish check-ins to users and spots. Chronologic saves those events off and then writes them to all the timelines that subscribe to that timeline. So Gowalla handles checking the subscribers and fanning out that write to a bunch of indexes. And then applications then consume those feeds that were created by Chronologic. So applications fetch a timeline and get back a fully materialized list of events, sub-events, and objects in one HTTP request. So you get back all of the check-ins or all of the pushes or all of the TPS reports for that one timeline. Any objects they might refer to, the user to include their avatar and a URL to their profile or whatever, and sub-events. So you can have, like in Gowalla, we have check-ins, and then you can post a photo or comment on a check-in, and so that appears as a sub-event on the check-in event. So again, I said Chronologic replicates objects that are referred to by events, and then it does, after it reads that timeline index and fetches the objects, fetches the events, fetches the sub-events, puts it all together, and sends it back to the application that uses it. So Chronologic is a service. It talks, applications talk to it via REST JSON API, It's implemented in Sinatra, and it talks to a Cassandra cluster via thrift. So that was pretty interesting. Pardon me. The internals. Objects are stored as replicated data into key blob pairs, just like we looked at earlier, though I might change this to use secondary indexes in the future. So this is basically what objects look like in Chronologic. You've got the key on the left, and then the column and value along the right. So there's a AK key, there's a column for username and age, and the value is the real Adam and 32. And these things can vary. So Houndstooth Coffee, you see that it has completely different columns and values. So, but this is all stored in one column family. So like many other NoSQL databases, Cassandra is roughly schemaless, though you can specify schema just enough that you can make performance optimizations. Subscriptions map timelines that are consumed as feeds to timelines that are written to by events or sometimes consumed as feeds. And then there's also a backlink for doing privacy checks. So there's basic support. So the backlinks are implemented now. In the next few weeks, I'm going to add support to privacy such that when you fetch a feed, you optionally say, I'm viewing this as Adam, and then when it pulls my feed, it will remove events from users that aren't friends with me or that are private and that I can't see. So Chronologic takes a fairly granular approach to doing the fan out right. It doesn't check for privacy at that moment, but it does check for privacy when things come back out. And that, I did some research into how like Facebook works, and that appears to be how they implement privacy, so I figured it was maybe good enough for me. So this is what that social graph looks like. You can see that user 1 follows me and I reciprocate, so the user 1 backlink is in that first column, but user 2 follows me, but they don't follow me back, so that link doesn't appear there. And you don't have to associate users to timelines. You can associate any kind of thing to any other kind of thing. So it's basically publish, subscribe, and that comes in handy in some cases for Gowalla. We have a region page for Austin that aggregates a bunch of interesting things about Austin, and we don't implement it right now this way, but we could implement it such that anytime you check in to say Torchies, it appears in the Austin feed via Chronologic. Events are all stored as key column structures. Each event is a blob, and it stores a timestamp that's used to generate the indexes. So this is what the events look like. Yeah, this is probably too much detail. Timelines are indexes. They map a feed to a series of events. And each row is one timeline. So this is what a timeline index looks like. So you've got some weird gobbledygook column name. The important part is that's sortable by Cassandra. And then the value is the name of the event that was stored back here. Or here, no. Somewhere else. So when you pull an event, you grab all these column names, and you grab the value, and then you grab the events that are referred to by those column values. So the still events. Okay, I just lost myself. Pardon me. When you publish an event, it's stored immediately into the events column family, and then each timeline is written to. That's the fan out part. When you refresh a timeline, the batch of columns are fetched from timelines and then pulled out of event. Events have sub-events, and so in this case, a timeline or an event can be its own timeline. So if you publish a sub-event to an event, then it has a link to that event set, and Chronologic knows to go look for the timelines for all the events it fetched first. So it grabs events and then then it knows which timelines to then recursively fetch to grab the sub-events. So even that made me cry too. I probably put those slides in the wrong place. So the API, this is the interesting part. You post objects or you delete objects. This is how you mirror users, spots, projects, whatever, into Chronologic. The social graph API, you set up the follow graph or the publish, subscribe metaphor using post to subscriptions or delete to subscriptions. There's a connection class in Chronologic that wraps all of this. The event API, you post events, that creates a new event, fans it out to all of the subscribers for that timeline. If you make a bad, then you can unpublish an event. So if you accidentally check in to Toys R Us or someplace that you don't want people to know you went, then you can remove it. And then when you want to grab the whole thing back, you just do a get on timelines, or you do a fetch. So these the names on the left are what they are, how they appear in the connection API, the Ruby wrapper. So let's look at how you actually use Chronologic. You create this connection class. It's got you specify where the Sinatra service is running. And then you create an event. So there's this event struct class. You create the event, you set the key, which is determined by your own application. Chronologic doesn't assign IDs to anything, so you're on your own to figure those out. You set a timestamp, which is really important because that's how the data is indexed. And then you throw some data, which is completely opaque to Cassandra and to Chronologic. So if this was a blog that we were building, then we would have a headline, a lead, and a body. And then we specify what timelines to write that event to. So we're just going to write it to the home page in this case, and then we're going to publish that event. We then use the connection to fetch the home timeline, and we get back a little feed hash, and it has a count attribute, so we can say we found so many events, and those events look like the items. So here's the output. You see we found one event, and then there's a data. So the event hash ends up just printing as a hash because it's really a hashy class. You see the timestamp. There are no sub-events, no objects, and the data came back. So we can take this and just shove it directly off to a template and start rendering it. We don't need to talk to any other systems. So that was kind of boring. There's got to be more we can do with this stuff. We can subscribe the tech category. Say we have a special subsection for technology posts. We can subscribe the home feed to technology posts. So now whenever we post to tech, it'll also appear on the home page. So the only difference here is the last line where we're saying that we want to post this to the tech feed. We publish the event just like normal. We fetch it just like normal. But now instead of getting back just that home, or instead of getting back just the thing posted to the home page, we get the thing that was posted to tech even though we fetched home. But it's all the same data. Events and stories beget sub-events. So we post some story to the home timeline again, and then someone comes along and comments, and they don't leave a very constructive comment. We set the parent, so we say that this sub-event, its parent, was this story 1 event, and that we should post it to the story 1 timeline. So now story 1 has become this kind of double duty thing where it's also the event and it's a timeline that maps to the activity for one event within Chronologic. So we fetch that, and now we get back the normal body and timestamp, but now the sub-events is populated with another event, pretty much just like you would expect it. It's comment 1, the message fell off the side there, but it's basically the same structure except now it has another event stuck inside it. And then, of course, if you're implementing an actual blog, you probably want to show the author of, link to the person who left this lame comment. So we're going to record 2 authors, Adam and Fred Derp. And so I post this this event. So you see the objects hash now has an author key, so you can specify different types of objects, and then you specify the key for every one of those objects. So author 1 posted this, author 2 posted the comment. Again, it's a sub-event, and we fetch it, and we get an even bigger hash. You see the sub-event has the objects, and it's got the user information inlined right into that object, and the same with the root story. So, a familiar situation, let's say we were modeling Gowalla. So first I'm going to record some of the developers at Gowalla, and then the Lone Star Ruby conference that we are at right now. I'm going to subscribe. So when I post to my passport, when I check in, Richard Schneeman is going to get it, and also Adam Michaela and Matt Thompson. When I check in, I say the message is I'm giving a talk. The objects is going to reference my user in the Lone Star Ruby conference spot, and then it's going to post to my timeline. And then someone is going to leave a comment. I believe it's Richard. So he says, I'm here too. We publish that event. And we pull, so if Richard pulls his timeline, he will see all this stuff, but Michaela and Matt Thompson will see it as well. So this is the structure that would come back. There is a nice wrapper around this, so you're not always programming against hashes. And that is corgis with lasers shooting out of their heads. So the future, I'm going to fix up the README, add protocol docs and API docs. Chronologic is by no means done. It is in production, but it's got a long way to go. And I didn't want to do like a vaporware thing and be like, oh, this is really awesome, and I promise you we're going to publish it. So I'm just going to let you watch me finish making the sausage of Chronologic. At some point, once we do a big release of Gowalla, I'm going to push a 1.0 gem. And in the meantime, we're going to use the crap out of it at Gowalla. There's a lot of places we want to use it, and we want to push it really hard. So other possible hijinks with Cassandra. I'm really excited about Cassandra. It makes it so that you don't have to worry about a lot of gnarly problems. And one of those gnarly problems, or one place I think is really ripe, like I said before, is to replace Redis use with Cassandra. So I've already started on a gem called SexyBack that aims to make it so that you can just drop in SexyBack instead of your Redis driver that you might be using right now. And instead of doing, and so when you do like a Z range by Zrev range by score or whatever, or H set or whatever in Redis, instead that's going to get written to Cassandra. And I think that has a lot of potential. Another item on my to-do list is to become the John Nunemaker of Cassandra. John's done a lot of great advocacy and built a lot of great tools for Mongo Mapper, so I'm going to try and follow in his footsteps. If I was Aaron Patterson, I'd have like my face getting awkwardly closer to his face, but I'm not that good. And then more distributed databases and fewer replicated sharded databases. There's a lot to be said about databases in the Dynamo style like Riak and Cassandra, and how not in both in scaling and performance, and also in operability, productionizing them, how well thought out they are, etc. So I would like to help people use more distributed databases. Oh, so it's go time now. It is time for me to release this software. So I'm going to do that right here once I tether it to my phone. And in the meantime, if we have questions, I'll take questions while I'm pushing software. Do you want me to go back to anything that I flew over to make sure I got through to the end? Back there?
Yeah, would you consider using this as a general pub-sub messaging infrastructure?
The question is, would this be useful as a pub-sub messaging infrastructure? If it's activity feed related, yes. Besides that, I haven't really done much pub-sub, and so I can't say with great confidence. It seems like doing it for things like IAMs or like brokers where you have nodes listening in on events generated by other nodes, it doesn't seem like it would be that great a system for that. Especially systems where the write volume is higher than the read volume.
Is the social graph tied to the concept of a user primitive, or it's social relationships between?
It's basically just a graph structure with that optional backlink that ends up getting used for privacy by Chronologic and by Gowalla. The graph doesn't need to be, I mean, they're just opaque strings to Chronologic. So they can be projects, they can be fictional things that have never existed, whatever. Anyone else?
So do you see this kind of like with comboing with, I guess, like other kinds of gems that maybe have the API for like Instagram or what have you? So that schema, the way that structure goes into Chronologic, it comes from somewhere else, or you dictate that structure? I mean, I guess, what's your take on how you guys are using this for the information that's going in?
So part of the question was, do you see like using Chronologic to as like a starter kit for a photo sharing service or a status sharing service or a check-in app or something like that? And that's an angle I hadn't thought of, but if someone builds that, I think that could be really interesting, where you just say, hey, here's Instagram in a box, use this Chronologic underneath, knock yourself out. One interesting tangent on that is that right now Chronologic is built on Cassandra, but by all means it doesn't need to be Cassandra based. I would love to see MySQL or Postgres backends, a Redis backend, a Mongo backend, whatever people happen to be using. It doesn't need to be something that you only use once you're over 1 million users. If you got a tiny little app, it would be great to be able to use Chronologic and its primitives to manage the feed instead of having to build those tables yourself. So if it interests you in using it for your application or for building starter kit versions of popular memes, then by all means, feel free to chip in with that. And there was a follow-up question? Okay. All right, so, I understand.
Adam, you had that slide where you talked about the durability and consistency. Do you have any lessons learned about what settings work for you guys, or you got bitten by inconsistency?
The question was durability, consistency settings. What's our experience with that with Cassandra? And the answer is, so I've tinkered with the write side of it. We haven't done a whole lot of read volume through Chronologic just yet. I tinkered with, at one point, so the default for the Ruby Cassandra driver is to use, you write to one node and then it asynchronously replicates to the other replicas. And that works just fine for us. I actually turned it up to the quorum level where it has to write to at least 2 of the 3 copies or a majority of the copies. I just did that to add load so that our graphs in Ganglia were prettier. But it didn't seem to decrease write performance noticeably or anything like that. I think for Chronologic we're going to end up something where there will be a flag for fetching a timeline where you say this timeline needs to be fetched with a higher consistency level, so that you verify that if I post something to a timeline, then immediately read it back, and we're asynchronously replicating, that at least I can see the stuff I just did. Other users don't need to see what I did right away, but if I post something and then I don't see it right away, then that leads to gnarly bugs and support issues. So that's about it. That's all the time I got. Thanks for your questions, and have a good day.